So the first operation is deep drawing. So basically, deep drawing is an operation where a cap-shaped product is obtained from a sheet metal with the help of punch and die. The sheet metal is held over the die by means of a blank holder to avoid defect in the product. So this is the sheet. This is subject to one punch. This is hold over the die. This is die. This is supported by this is called blank holder. Blank holder. This is punch. This is workpiece. This is subject to some force F. So in deep drawing, a cap-shaped product is obtained from a flat sheet metal with the help of punch and die. The sheet metal is held over the die by means of a blank holder to avoid defects in the product. So basically, when the depth of the cup is more than its diameter, it is called deep drawing. On the other hand, a depth of cap is less than diameter, then it is called as shallow drawing. So here we are talking about deep drawing and considering that the depth of cap is more than diameter. So the annular portion of sheet metal workpiece between the blank holder and the die is subject to pure radial drawing. On the other hand, the portion of workpiece around the corner of the punch and die are subject to bending operation. Further, the portion of job between punch and die will undergo a longitudinal drawing. So this is the important. The annular portion of set metal between the blank holder and the die is subject to pure radial drawing, whereas portion of workpiece around the corner of the punch and the die are subjected to bending operation. Further, the portion of the jaw between the punch and the die walls undergoes a longitudinal drawing. Let us calculate the blank dia with the data of punch and the drawn cup. So blank diameter. So suppose we have given a punch and all data of punch is known. So this is the punch having diameter dp and small r is the corner radius. So let dp is the diameter of punch, small r is the corner radius. Now similarly, the height of the funnel cup is h. Small h is the height of cap. So the blank dia from which the cup will be made, capital D will be under root dp square plus 4 dp into small h. So this will be, if dp will be more than or equal to 20r, or the diameter of the blank, so diameter of the blank will be under root dp square plus 4 times dp into h minus 0.5 r if the diameter of punch will lie from 15 r to 20 r, or diameter of blank will be diameter of punch square plus 4 dp into h minus r if the diameter of punch lie from 10r to 15r. So based on this calculation, we can calculate the diameter of punch. This is P. Next process is bending. So bending is the process of bending a sheet metal plastically to obtain the desired shape, and this is done by a set of suitably designed punch and die. So it is the process of bending a sheet metal plastically to obtain the desired shape. This is achieved by a set of suitably designed punch and die. here this is the die, this is called as die. So there is the punch. So the sheet metal bends like this. So this is the sheet metal. So here bending pressure is applied with the help of some punch. So this is the bend, and normally there is some spring back effect occurs. So let us calculate that portion. Let us see spring back. So in case of plastic deformation, when at the end of metal working operation, the pressure on the metal is released, there is an elastic recovery by the material, and the total deformation will get reduced by a little amount. So this phenomena is called as spring back. So in plastic deformation, when load is completely removed, there is an elastic recovery by the material, and the total deformation get reduced by little amount. So this phenomena is called spring back. So let us calculate the value of spring back. So this is the area under tension. So we will take this as the bend angle. From here the bending takes place. This is the portion, so this is called bend angle. This is alpha. This part is area under compression, and this line is called a bend line. This is the neutral axis. This is the bend radius capital R. So bend allowance B equal to alpha R plus KT, where alpha is the bend angle, this is in radian. Capital R is the inside radius of bend. Inside radius of bend. Capital K is the location of neutral axis from bottom surface. The value is 0.33 when R is less than 2 times thickness, or this is 0.50 when capital R is more than 2t, and this small t is the sheet thickness. This is in mm. Now let us see punching and blanking, or piercing and blanking. So blanking and punching. So punching is also known as piercing. So in case of blanking, so first we'll see about blanking. So it is a process in which the punch removes a portion of material from the stock which is a strip of metal of necessary thickness and width. The removed portion is called blank and is usually further processed for some use, such as blanking of a padlock key. So suppose this is one of the sheet metal. So we will remove one part. So this will be called as blank and this will be scrap, the remaining part, and the process will be called as blanking. Now next one is the piercing or punching. So punching or piercing is the process of making holes in a sheet it is identical to blanking except that of the fact that the punched out portion coming out through the die in piercing oblique punching is scrap. For example, we have made hole, the, the part has come here. So this is scrap. This is useful and the operation will be called as punching. So this is one of the important fact. So in blanking, the die size is same as the component size, whereas in piercing. The punch size is the same as actual hole size to be obtained. So based on this fact, many questions are being asked every year in GATE examination. So we will take one problem based on our fact. And normally one of the fact is also there. The clearance between punch and die is taken at 7% of the steel sheet thickness. So the clearance between punch and die is 7% of sheet thickness. So we will take one problem. Determine the size of die and punch in blanking and punching operation for a circular disc of 20 mm diameter whose sheet thickness is 1.5 mm. So let us solve the problem. So we can say the clearance will be 0.07 into steel thickness, so 0.07 into 1.5, so this will be 0.1 mm. So now first we will take blanking operation. So we know that in case of blanking operation, die size is same as the blank size. So die size will be blank size. So this is 20 mm and the punch size will be die size or blank size minus 2c. 2c is the clearance. So 20 minus 2 into 0.1. So this will be 19.8 mm. Suppose it is punching operation. Then the punch size will be blank size. On the other hand, the die size will be punch size or blank size plus 2c. So this is 20 plus 2 into 0.1. So this will be 22.2 mm. So in this way the question are being asked in the GATE examination. Now next one is the notching. Here the material is removed from the side of a sheet metal. For example, this is the sheet metal. So material is being removed from the side of the sheet metal. So this part we are removing. So this part is not there. So this is the material. So this part is will be called as notching. So here material is removed from the side of a sheet metal. Now next is the lancing operation. So in case of lancing, we cut part way through the metal without producing any scrap. Lancing is frequently combined with bending to form tabs. So this is the sheet metal. So it is cut like this way, but we don't any scrap. So lancing make cuts part way through the metal without producing any scrap. Lancing is frequently combined with bending to form tabs. Then slitting. So slitting is an operation to cut a coiled sheet metal lengthwise to produce narrower strips. So suppose this is one of the sheet metal is there, so we cut here from here. So this will become sheet number 1, this will become sheet number 2, sheet number 3. So these sheet will be narrower. Slitting is an operation to cut a coiled sheet metal lengthwise to produce narrower strips. So the next is nibbling. So basically, nibbling operation, the complicated shapes are cut from a sheet metal by producing overlapping notches starting either from the outer boundary or from a punched hole. So here complicated shapes are cut from a sheet metal by producing overlapping notches starting either from the outer boundary or from a punched hole. And the last one is called trimming. So trimming is the operation of removal of excess material in a flange or flash. So trimming is a process of removal of excess material in a flange or